Okay, so day 2 of logarithms. Day 2. Today we are focusing not on evaluating, which is what we did yesterday when we get an answer, a numerical answer, by putting it in the calculator. Today we are rewriting them. We need to be able to rewrite a logarithm as an exponential statement. And we need to be able to take an exponential statement and go backwards and turn it into a logarithmic statement. Super crucial to solving equations. I cannot stress. This is probably one of our top skills that we learn with logarithms because it makes life super easy. Now, we call this the loop-de-loop. Okay, this is called the loop-de-loop, like SpongeBob's loop-de-loop and pull. Shoes are looking cool. On the left, I have my logarithm statement. Log of base b of v equals our exponent. This is the exact same thing as b to the exponent equals v. Okay, so look at where our values go. Our base becomes what holds the exponent, the big number that has the exponent. The base of a logarithm becomes the base of the exponent. A logarithm is equal to an exponent always, and that exponent becomes the base's exponent. And notice, our log is gone now. We got rid of our log by rewriting it as the base to the power of the exponent. And this is going to equal that inside value. And you could go backwards. You could start on the right side, write down a log, put the base as the little tiny baby number by the g, put our value in our parentheses, and it's always equal to an exponent. Just remember, logs find an exponent, exponentials, this is an exponential, they find values. They find an answer, a value answer. So let's try the loop-de-loop. Write down example 1. I'm putting up the shade. Remember how. Yeah, I don't know how. Is it right here? Write down example 1. Now, if I were to sit here and challenge you to find x, it would not be easy, right? I cannot take my calculator and type in log of 8 base x. That's not going to help us find anything, right? See where the x is? How am I going to find that? When it's written as a logarithm, it's not easy to find that x. I can't type in log base 8 of x equals 3 into my calculator and it magically finds x. However, hidden in disguise is this is a very simple problem. We just need to know how to rewrite it. So here is where the loop-de-loop comes into play. I always start at my base and the loop-de-loop begins. Watch the loop-de-loop. Are you ready? We start at our base. We loop to our 3, and up and around to our value, the loop-de-loop. This gives us a map of how to rewrite a logarithm. Right now it's a logarithm. I'm going to write it as an exponential, which means the log disappears. We don't want a log. We're going from a log to no log. So I start with my base. My base is 8. To the power of 3, because this is our base.
So 64 times 8.
This is our exponent. And it's going to be equal to the x. Is this a lot easier to plug into our calculator? What can we plug in our calculator? We can just plug in 8 to the power of 3. that's our x. So we know how to do that. We turn on our calculator. I'll make it nice and big and pretty. 8 to the power of 3 is going to be our x, which is our value in this problem. Enter. What is 8 to the power of 3? 512. So that means x equals 512. And look, we can check. That means if I were to type into my calculator log base 8 of 512, what should I get in my calculator? I should get 3. Look, I'm going to do it. If I type in log base 8 of 512, the x I just found, I get 3. So that checks out. That works. Number 2. Tricky. Why is number 2 tricky? Why would I do this?
Fraction.
There is a fraction. That is one trick. There's another one. It doesn't look like we have a base, but what base is really there?
10.
A 10. Common logs, a log without a base that we can see, defaults to 10. So it's good of you to write in your base. This is base 10. It is a common log. It looks like there is no base there, but there is. It is a 10, and that is where we begin our loop-de-loop. We start here. Draw your loop-de-loop. 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 Get a barrel row.
No.
Yep. We start at 10. That's our base. If I'm talking to myself while I do this problem, I am thinking 10 to the power of 3/4 is going to equal what? X. Our base to the power of our exponent equals our value. 10 to the power of 3/4 equals x. Let us find out what x equals with our handy-dandy. What is 10 to the power of 3/4? Whatever that is our x we are looking for. Probably. 10 to the power of 3/4. We get a long decimal. How many decimal places do we go out?
All the way to the 3.
All the way to the 3. And we look behind it, there's a 4, so it's going to stay the same. 5.623. That is our value we're looking for. If you raise 10 to the power of 3/4, you get 5.623. If I want to check, I'm going to go into my calculator. If I plug my x back into my log, math, log base of 10, which I could have just used common log, of 5.623, I get 0.74996. Is that close to 3/4? Yeah, because 3/4 is what? 0.75. So very close. It's a good answer. Now it's your turn to shine. Haha, or is it? Think about this problem. Think about, your first instinct should be, what kind of log do I have? What kind of log is this? Natural log. And although I don't really see a base when I look up there, my base is E. So it is helpful to write in your base. This log has base E. Again, we don't write it because mathematicians are lazy. They created a special log so they didn't have to write as much. ln is just log base e. Start at your base, and we begin the loop-de-loop. E to the power of 2.5 equals x. E to the power of 2.5 equals our mystery value x we're trying to find out. You don't remember, E is in your calculator. It is in two different spots. If you want to type in just a plain old E, it's on the division button. You just have to click the second blue button first. If you want to do E to the power of something, you do second log. Oh, sorry, it's not second ln. And there's your E to a power. And we want E to the power of 2.5. We click enter, and we're going to get a nasty decimal. We get 12.182. E to the power of what is, or E to the power of 2.5 is 12.182. If we were to plug in the ln of 12.182, we would get really close to 2.5. How is that? The schloop-de-loop. Good? Okay. Now we just have a few more, and then you'll be on your way today. We're going to do the same exact thing, but backwards. Now we're going to be starting with an exponential, and we're going to write it as a logarithm. Which means we're going to have to write the word log, or ln. Don't forget your base and all the good stuff. So here we go. E to the power of x equals 27.95. And this is exactly why logs exist. Because I have no idea what power you would raise e to get 27.95. No idea. We could sit here and guess all period until we find it, or we can use a logarithm. So we still use the loop-de-loop method. We start at our base, which is e, and I do the loop-de-loop. Loop-de-loop around. This time when I write it, I need to use a log. What base is my log going to have? It's going to be a log of base e, which is the natural log. We're not going to write log base e because we have a special log for that. This is going to be ln. Remember, this ln has a base e. So it's going to be the ln of our value, which is 27.95. And this is going to be equal to, what's it equal to? Equal to x. Because logarithms are always finding the exponent. So it's always equal to whatever the exponent is. In this case, our exponent was x. And easy peasy, we just type it in like we did yesterday. The ln of 27.95. ln 27.95, and click enter. And I get the value of x. X equals 3.330. And I have turned an exponential into a logarithm. Backwards. Two more. Number 2. 10 to the power of x equals 12 over 7. Who knows what our x could be? We could sit here and guess all day, but that's not very efficient, so we have a world of logs to use. So in number 2, what is our base? Find the base. Base. What's the base? The base is 10. That's what holds the exponent. We start there and we loop-de-loop. We loop over to the value and loop all the way back around to the exponent, because logs are equal to exponents. What kind of log has a base of 10? Just a common log. So do we have to write log with a little 10? You don't have to. You could just write log. This is the special common log. We don't need to write log with the little base 10. That's the common one. We can write log, and then whoever's looking at our paper assumes it's a 10. On the inside of this log is going to be what value? 12 over 7. And this is going to find us the exponent that we're missing. Now it's just a matter of plug and chug. Plug and chug. Plug and chug. Click the common log button. We don't need the special log. We just go common log. 12 divided by 7. And we get 0.234. This means if you raise 10 to the power of 0.234, you'll get about whatever 12 sevenths is. Well, somewhere between 1 and 2. One last one. Then you'll be on your way. Number 3. 4 to the power of x, or 4 to the power of what, equals 20. A perfect question that can be answered by a logarithm. Because that's what logarithms do. They find the exponent that needs to be raised to find a value. This time, we're going to have a special log, right? We can't use the natural log. We can't use the common log, because what's the base of our log going to be? 4. So we have to actually write the 4. Log of base 4 of 20 equals our mystery exponent that we need to find. Which means I cannot use the log button. I cannot use the ln button on my calculator. I must go to my math menu, go all the way down to the bottom where it says log base, so I can actually put in the base that I want. I want to have a base of 4. I'm trying to figure out 4 to what power gives us 20. So I put 20 in my log. And this is going to figure out what exponent I need to turn a 4 into a 20. Click enter, and I get... Yeah, that's exactly what you should put. 2.161. And again, you can always check these. 4 to the power of 2.161. This should be extremely close to 20. Which it is, 20.00099684. Very close to 20, but we rounded, so it's not perfect. And that is how we rewrite from logarithm to exponential to logarithm, which is very vital in solving equations.